As always, I'm going to begin with some example code. And today we're going to use it a bit more than usual. First of all, we're going to create a class to store settings. Good old settings class. And in this class, we're going to add... First, let's do an integer. And player count, and just use a property, and then we should add constructor. That sounds good. Topic settings. I'm a bit out of it, sorry. Hoping the weather doesn't interrupt us. There was a thunderstorm. I'm hoping the power will not get knocked out. I mean, it has passed, but somewhere down the road it might still hit one of the power lines, and then sometimes we get a brief power outage here for a few seconds only, but that would be very annoying if you have the PC running. And I have turned off the power supply. It's an external thing, and that's pretty loud. I didn't want to have that running during the stream. So I'm still a bit nervous, hoping that everything just works out. Well, we have constructor, and then we can create a new settings instance with player count 4, for example. Let's remove this. So now we have the class containing settings. And let's make a second class that uses these settings. Game session. That works. And it will internally... No, let's not make that public. Let's make a private. Actually, private read-only. Read-only settings. Not the settings. That, and yeah. Like that. Close the brackets. And we have a game session. Game session. Builds new. We pass on settings. Right, so pretty straightforward. Let's add some code that actually uses our settings. And this session will keep track of the players in two ways. We're gonna store, first of all, the levels. Let's maybe player levels. Let's write it out. Player levels and player health. Oh. Yeah, it's not player, it's player. Like that, and player levels equals new int with settings.player count. And we can do the same for player health. And then we should add a simple loop. I should maybe turn on the light. That would help me to see the keyboard. Maybe not mistype so much. Starting at 0. Serious, what's going on? I'm kind of confused right now why I'm so bad at this. Something isn't right. Also, I think the sound isn't right. Wait. Let's turn down the gain. This should be a bit better. Maybe like that. I think that's okay. Have to check the VOD later on. Player help. Maybe move the microphone. That could help. Talking into the microphone is usually better than talking sideways. It's also not quite... no. Whatever. I have to completely replace the microphone, as in place it somewhere else. It's currently not a good setup. And some parts are falling apart. To tighten some screws here, I think. Anyway, player levels I equals, we start at level 1 and player health starts at 100. Alright, so this game session will now get the settings from us, and the settings contain a player code of 4, so this game session will contain 4 integers for level and 4 for health, matching each player in our game. Well, let's say I want to have another game session. Game session, second session. Right, and can give it another settings object, or the same, sure. Maybe I want to have a different amount of players this time though. Maybe this time I would only want a single player. Works perfectly fine. I can set player count to 1, pass it on the constructor, and it will create only a single entry in each array. That's fine. There's a problem though. Once I add a certain method here. Let's say I have a method, a void method, level up, that just increases the level for each player and resets their health. So we're just gonna copy this out, go into the entire array, and instead of setting it to 1, we just increase it by 1, the level, and reset health to 100. This works, theory. So game session.levelup would be fine. Sex session.levelup would also work just fine. Actually, let's just try it. Let's just compile, try the code, see if it caused any issues. Nope, didn't break, no exceptions, it just ran. So everything worked, right? So code is good. Except when I switch this around, everything still works. Oh, that means everything works perfectly fine, right? So there are no weird issues with the value just changing. Well, let's try the level up again on the first session. Oh no. No, it broke. But why? Well, obviously, because settings suddenly expected a different number of players than it was initialized with. Because we use the same object for 2 different sessions, and by changing the value for the second session, we also change it for the first session. It's a side effect of us reusing the value. It's mutable, we can change it, so the old session will also have a different value. And the way we wrote it here, it kind of expected it to not change. So, 2 ways to deal with this. We can either use code that doesn't expect it to stay the same, and we could instead focus just on the player levels .length instead of player count. But the other, the more sensible maybe, is to not have the same instance for settings for both game sessions. But it's so convenient to use the same value again, especially once we increase the amount of settings that we have in here. Let's say I have another integer starting level and starting level on maximum health, and I'm gonna use those starting level and maximum health, and then here as well. It also means I have to add them to the constructor, right? And starting level and maximum health, like that. I can create that once up here. Player count 1, starting level 1, health 100. And then I just change the player count and reuse it for a second session. Much more convenient than writing out a completely new session with all 3 variables filled. Or potentially even more if there are more settings I have to do. Well, first step should maybe be not allowing to change this value, just for safety. We can only set that in the constructor once, and that's it. Then we get an error here telling us we can't change it. It's read only. And our code can now be sure to rely on this settings object because no one can change the values in it. We can reuse it, certainly. That's not an issue. So if I have a second session with the same settings, we can just reuse it and there are no issues because we made sure no one can change the values. But that makes setting up the second session a bit more annoying. Okay. For that kind of thing, to make things a bit easier, there's this idea of a copy constructor, where you just take, let's just name it copy, where you take an instance of the same object, and when you initialize everything, take the values of the provided instance and paste them into your own. You copy all the values one by one. Right, so we could make settings, second settings equals new, and then provide the old settings, and we create a copy of the previous settings for the second session. But that still leaves us with the issue of it's the same values. We wanted to change them. Well, we could make a copy constructor that accepts those values as well, right? So we can override them if we want to. One easy way would be to make this nullable and allow null as a default value. And then for each of these, we can say player count, the null coalescent operator. That forces us to use either the player count if we provide one, or to default to the original or the copy value for player count if we provided nothing, or just null. That maximum health, like so. Now I can create the old settings and I can just provide a different player count, 4. So I use the original settings with a different player count. If I want to change maybe the health, I can specifically name the variable I want to change, override, and do it like that. But it does work. But maybe not in all circumstances. Right now, I'm only using integer values, so making them nullable and providing null as a null value is fine, but maybe you actually want to have null as a legitimate value in here. Maybe have something like public string session name, or maybe not session name, what about server name? That might be more interesting. And this might be nullable because you not always need a server. And now adding this as a nullable doesn't make sense because null itself could be the actual value and you need to find some other way to distinguish between did I paste in something from the outside or is that the neutral value I provide as an optional value in the constructor? So not always the best option. There's luckily something else we could use, that is also conveniently easier to write out. You can remove all of this. And it has to do with a certain option we have when creating new instances of an object. Let's say we have, let's return to the old set methods. Let's say this is mutable. Let's say we can change all the values later on. We could use the object initializer. I'm not sure if you can remember that, but we always have the option, instead of having a constructor like this, you can have the default constructor or constructor with only partial values covered, and everything can alternatively be set explicitly in an object initializer part with access to all the writable properties, and we can give them a different value. And that's part of the initialization, the constructor call. Oh, not of the constructor call, it's calling the constructor first and then setting the values, and then it returns the initialized settings object. There's another way we can use that doesn't give up our immutability. This is only in the newer C# versions, but we have this keyword init now. And init behaves like set as far as the constructor itself and the object initializer are concerned. But it still won't allow us to change the value later on. So if I have the finished instance, I cannot write anymore. Init is basically like a read-only. It doesn't allow us to write, except during initialization, which is the constructor itself and also the object initializer, which is tied to the construction itself, which also can only happen once. So that's still in scope of init. You can also use init for full-on. Okay, this is a bit problematic. And the next version of C#, I think it was only next, you would have now a field keyword we could use. Otherwise, you would set up an actual field in the background you set for player count, and you can access it through init. You can also write from one init method to another. This is still part of the init initialization, so you can also use it in here. Not prepared well enough, I think. Oh well. Yeah, init. That allows us to add the object initializer, which gives us a very convenient way to write values without specifically adding them in the constructor. And we can do that for the copy constructor now as well. So we make the copy of the original using the copy constructor, which specifically copies out the value for each property. And then we can modify player count freely, explicitly to some other value, and use that new instance, which will have a player count of 4 now. So we can use all the old values, exactly the settings we used before, just with explicit changes using the object initializer. So now we have a settings object that is immutable, in the sense that the values we see once in there will be the same values we always see in there. So if we use the settings instance to initialize our game session, we can be sure these same settings will still be there when we later just use our game session. Doesn't matter how much time has passed, it will be the same value. So using the player count down here lines up with using the player count up here. It will be the same value, so this will always be the length of player levels and player health, and we can reuse it everywhere. Just fine. let's also override the toString method, because seeing all these different values might be helpful for us. Let's just quickly override the toString method, and I'm gonna make this simple. Let's see. Players equals player count, and level equals, just cutting it short a bit here, health equals maximum health, like that. And now we can, well, we can for one look at all of that in a debugger. And we could also output that in the toString method, or in a simple console write line, or any other output, maybe logging. We can just use the toString method of settings to get this string. Players equals 1, level 1, health 100. And for the second settings, we'll get players 4, level 1, health 100. So nice readable version of the settings in the debugger window, or in the output if I want to. Settings. Let's do that also for the second session settings. Two different settings, printed out very quickly, very conveniently. And let's actually do a bit more. While we're up here, maybe we want to check different settings, we compare them. Are the settings we used for session 1 the same settings we used for session 2? Well, there's an equals method we can use. And the equals method will compare the two different settings. Oh, I should use the correct property, correct variable. Compare the two settings and tell us if they are equal. The only problem here is that the default equals method we always have, we inherit that from object, the base class for everything. It will compare only the actual pointer, basically, in our case. An object reference. Is it literally the exact same instance? Even if I don't change player count and I have the exact copy, it's not the same. Same settings is false. So to make this usable, we would have to override the make available, or basically we just have to override the equals method, and I just use some code generation automatically in the background that will add the equals method for our three properties. We override the default equal, and we also get the get hashcode method, which you also should override if you override the equals. And now I can compare, and same settings is true, because settings and second settings have the exact same values, even though they are different objects. And once I change this back to player count equals 4, well, they're not equal anymore, so now it's false. Cool, so that all worked out. Writing all of this out, however, takes a bit of time. That's a bit... There's so much extra stuff to write out here, just for some very basic functionality. I mean, there's not really much thought in this. We have the constructor, which just straight up takes my values and puts them into these properties directly. We have the copy constructor, which just copies the values one by one exactly. We have the toString method, which simply outputs a toString version of each of those properties. And we have the equals method, which just compares all those properties one by one without anything else. Even the get hashcode is a pretty standard version, which just takes all the properties and combines them to a hashcode. By the way, the hashcode class, it's also only in the newer .NET versions, not on the old one, where you still had to make this all manually, which would actually be even more work. So this is already the shorter version, and it's still a hassle to write out, especially because now every time you add another property here, another setting, you have to remember to add it to the constructor here, to the constructor here, to the toString method, the equals method, and the getHashCode. And that's assuming you don't have even further methods that involve the properties that have to be extended. Because this is quite common, this type of thing, this type of class structure, there is a simplification. Let's just accept the class as it is right now. Let's keep it here. We make another structure now. Make another class, game settings, right? Another class game settings, which will have the exact same properties and the same behavior overall. But we don't want to do that ourselves. So we add a simple keyword up here, record. And as you can see right now, this is a bit phased out, this class, because it's optional. You can actually just write a record. You can treat it like a separate type of structure, like class, struct, record. So technically with newer versions we have the option to choose a record class, which is the original record, or we can use a record struct, which is the same thing we're gonna see in a moment, just as a value type instead of a reference type. But otherwise it's the same thing. We're just gonna stick with record class, which is just record. And one thing we can do with the records, what's the usual way to handle this, we don't add the properties in here. We don't write them out like in the class. We do something else. Actually, maybe I should show you something before that. Just a side note that it's possibility and plus demonstration. Public int. Let's do it like that. Public int bar. Like that. You can use, of course, constructor. Public demonstration. Like that. But with the newer versions, you can also instead put that line up there and then write foo in here and bar in there, not barrier. Bar, like that. That's better. This has the exact same behavior. So what we did here is we provided in the definition for the class itself also essentially the arguments for a default constructor of sorts. When I create a demonstration, I don't have the default constructor anymore, the one without any arguments. Instead, I have one that accepts 2 integers. And internally, it will just take these 2 integers and assign them to our 2 properties. So if we go in here, look in demonstration, we will find 40 and 10 for foo and bar, as if we use the default standard method of just having a constructor in here. Whoop, that was too many. So this can be shortened to this in the newer versions of C#, the .NET framework, .NET, not framework. And the same style can be used for records, and it's the more common way to do things, for records at least. I can just define the properties directly in here. So I have player count. You notice also how I write the names in uppercase now, not in lower. That's not an accident, that is intentional. In starting level. And maximum help. And I leave the rest actually empty. In fact, because I leave this block empty, I can reduce it to just semicolon, as if this was some code block that I instead replaced with a one-liner. So I can just use semicolon without any curly brackets and I'm done. This one line has the entire functionality we've defined in this thing. So what do we have here? Settings. Around 50 lines of code replaced with this one line. Let's try using it. So up here, instead of settings, we are going to use game settings. And the constructor is defined in here, exactly for these properties. We need to change game session, of course, to store game settings. But otherwise it will not complain. The settings still have the properties, starting level, maximum health, and player count, so game session is happy. The only thing that doesn't work anymore is our copy constructor. The syntax isn't exactly the same as it is for our class here. Because for records, this copying is basically a default functionality, not something we have to explicitly add later on. So we don't need to add a copy constructor. It already has the built-in feature for copying the data and modifying it. Let's actually keep the old line. So this is what we used with the copy constructor before. We're actually going to keep this part here because this is very convenient. And we're going to keep the settings because we need that. But instead of using this as an argument in a constructor, we're going to add a keyword with. Settings is now a game settings, which is a record. So the keyword with on a record means take that record as it is, make a full copy of that, just what we did down here, and then apply changes if necessary. So we change player count to 4. Could also leave this empty, make no changes. Though in that case, making a copy might not be really sensible and you might just want to directly use the reference. But in our case, we want a different player count. That's why we created the second session, because we wanted a different count of players. So I changed this, and the same syntax we use for object initializers. I can also just use a comma and change maximum health to 1 maybe. Just as with an object initializer. It's the same structure, basically. These 3 integers we have up here in the record, they are automatically translated into 3 properties, just like these. You can treat them not just like these properties as same type, same name, and with an get and an init. So we can construct them just up here with exactly those values, and we can use the keyword with and an object initializer to change the values. We could also add some normal properties. Public string. Let's use the server name from earlier. Server name, get, set. So we might be able to change it later on. This is another property. We specified that explicitly down here inside the scope of the game settings in these curly brackets, so it's not part of the constructor. We can change it in here with the object initializer. And we can also change it, of course, later on, because so far it's a set. You might want to change this to an init, and so it's saved now in here. What about the other functions? Let's reduce that again to... Actually, no, let's leave that in here. Let's leave the server name in here. The output should still work just fine, right? We didn't really check that earlier. Oh, right. Should keep the console open. You can see the syntax is a bit different from before. We have the standard format of the type name, and then in the square brackets we list all the properties and their values separated by commas. But it is still an output of the internal structure. Copying the data still works just fine. That's what we have special syntax here for. And equality comparison, well, let's make a breakpoint in there. They're not the same settings, player count is different. Let's change the player count to exactly 1, so we have the same result. No, they are equal. So equality checks also work out. This thing does indeed compare to this entire construct we have here, using the new language features. That is a record. Very convenient tool. And again, we could turn this into a record struct. But it would still behave the same way. Just this time we have a value type, not a reference type. And record structs are a bit newer, so if you're not on the newest versions, then you might also only have record as in record class. I'm not sure when record structs were introduced, but I haven't used record structs so far. Whenever I use records, I use them to replace basically these classes. And they have been good to me so far. I really like records. Plus the whole immutability is only really a feature if you have reference types anyway. I mean, once I declare this a struct, then passing on the struct to game session here would create a full copy anyway. Because it's a value type, we create a full copy of everything, and so there are no side effects anymore. Those only exist because our old settings were a class, so the exact same space and memory would be used for our first game session and the second session. A record struct, I'm not sure when you would use a record struct. I'm using record whenever I want a reference type and I want it to be immutable, because records are so much more convenient to write out than all of this. Plus, easy to expand. Let's use bool. Bool. Low. Oh, wait. Low. Level up. Just write it in here, and suddenly we have fourth property defined in the constructor, and everyone has access to it. All the functions, the equals, the strings, the copies, everything automatically has access to it. So if settings dot level up, not return. So far for records. Let's just get rid of this one. So this, just to make this a bit clearer. Let's have a look at our two arrays in here, in the game session. Right now, play levels and player health are just two integer arrays. So let's say I add another method in here. Public int get highest level. If I want to just get the currently highest level in the party, Oh no, actually leveling doesn't make sense. They level up all at the same time. Get highest health. That. I could go for return player health dot max. If we want to make it simple, just use the link extension. We could go the classic route and just iterate through all the different players. Actually, let's do that. Max equals, let's do 0. Assuming that the health can never go below 0. Less than max. Oh, that actually makes no sense. I wanted to have the highest is greater than max. Then max equals I. Return max. Yeah. This is why I prefer the extension. It's a bit easier to write out. So this way I can just go to the game session and ask, hey, second session, give me your highest player stat. There's an issue here where if we assume a multi-threaded environment, which I tend to assume in all cases, especially for a game, you probably have a lot of things going on. You have the engine and the rendering and maybe some networking. You will have multi-threading in mind. And that means at some point we might have a case of a level up happening at the same time another system needs to check the maximum health. And that might cause conflicts, because we try to evaluate the health, are maybe halfway through the players, and then the level up happens and all player health get reset to 100. And now we compare the first half of the player health before the level up and the player health after the level up, which doesn't make much sense. The direct way around that, something we learned, is the whole read-only locking mechanism for multi-threading. So let's do lock equals a new lock. Last time I showed you lock, I used just object, but I'm using a newer C# version. I want to use the new features now, so instead I'm using the lock class. That is specifically for that scenario. You can use object just the same, that's fine. If you still have object, use object. And I can just put a lock around the whole method. Let's put it in here as well. And now those methods are atomic. Only one method can run at a time, so we always make the level up, and then we get the highest health check, and then maybe the highest level up again, but maybe level up again. So we make sure that whenever these methods check the array or use the values in the array, they do it in one go, and they have a consistent display of values from one specific point in time. But now we might run into an issue with performance at some point. And maybe we start to forget that this health array needs to be dealt with securely. So we maybe loosen the conditions for the lock a bit. For example, some programmer might get the brilliant idea of just copying this. And copy, or let's just call health. And we use the lock for just health equals player health. And then we just use that array. Brilliant. Now we just block the access for one single access. And after that, multi-threading is enabled again. So while we go through the copy of our array, the others can use the array again. Isn't that great? Except, of course, we copy the reference, so this doesn't work, so we do actually need to make a copy constructor in here that goes through the entire array and first initializes the new array, then goes through everything and makes a copy, and that's what we use and then throw away quickly. I mean, it's not the worst idea, but you always have to remember to do this. And you always have to remember that whenever someone edits the code in your class, you have to keep in mind, hey, I can't just edit health directly. I have to be careful. I have to always add the log around it somehow. Be careful of when to change the values and when to keep them and whatnot. An easy way around that would be to just prevent anyone from changing the values of health. Might sound weird right now, but what if we made player health also immutable, just like our game settings? Okay, first instinct, make it read-only. But that only changes the access to the reference, but not to the values inside. So read-only, maybe not the way forward. There's another thing we can do. There are other types instead of int arrays. For example, we can just change this to a list, right? Doesn't need to be an array explicitly. For the most part, list would work as well. And instead of using your int here, list in your list, we can even set the capacity already. This is player count, and instead of this, we can do player.add settings.maximum health, like that. All right, we can do that. And if we can do list, we can also do, oh, wrong one, read-only collection. Read-only collection is what it says in the name. It's a collection that you can only read from. I cannot write to it. So for example, the add method doesn't exist, cannot use it. Or the player health down here. I can't set the value anymore, it's read-only. I can still read it just fine, that's not an issue. So the to array would work, and I can also just go for player health directly. And read it, just fine. So read-only collection is a way forward. We would need to change the code a bit here. Read-only collection cannot be initialized directly because it cannot be written to. We have to first create another collection of some sort, like a list. Like that. And then we can initialize a new read-only list and pass on our existing collection, our list. Read-only collection takes our list that we initialized internally in the constructor and wraps around it and puts that in player health. So when we access player health, what we actually do is we access this list internally. It's just hidden so that access to the methods that set the list, that change anything there, are not accessible anymore. That's why I get an error here. The list internally is still there and I can call its method, but it's blocked by the wrapper around it. And the read-only also exists for other data structures, but the idea is always the same. You have basically just a wrapper around an existing data structure that gives you direct access to all the methods that read your data, but block access to all the methods that write or change data. And because that's hidden inside, this might not be good enough for you. Because if you paid attention last time, you know it's easy enough to get access to internal stuff. We can easily enough get access to the list that is stored inside the read-only collection with reflections, for example. Even more interesting, maybe this read-only collection here. Now let's do private list and internal help list. Maybe that's what we actually store in there. Like that. So when we use player help, we don't have access, but we can use the internal list. Now we have two ways to access this list. We have the list directly, and we have this wrapper that wraps around this exact list and only provides read access. And sometimes you would do this kind of thing. You would have a public component that's a read-only collection that's wrapping around an internal private list. So your code itself might have still access to it and can change it and write it, but people that access the data publicly only get the wrapper version to prevent access to write it. That's not the case for us, however. We have it already private, and we wanted to prevent other developers from accidentally, and I mean accidentally, changing the values without understanding the context fully. And so having the variable for the list just exist temporarily inside the constructor and otherwise only stored as a field privated inside the read-only collection instance is a good way, and was for a long time the only way. And then came the new classes we got, or not classes, the new types we got with the newer C# versions and the new .NET versions. And one of them is ImmutableArray. ImmutableArray is a value type, by the way, though it stores internally a reference to an array. So ImmutableArray is not so much different than a list. Internally, it stores an array that has all the values, and you access everything through that array. But this internal array can only be read from. The immutable array, the class, or the struct, it's a value type, it's a struct, does not provide any methods to change the values in its internal array other than list. So I would need to go back to the old structure I had here before. We first fill the list internally, and then we create a new immutable array. And there are a couple of ways to do that. We could go for ImmutableArray.create. Did I do it wrong? Was it the wrong? Did it not accept an IEnumerable? Oh, create range. It was create range, not create. Okay, like that. So we don't call the constructor, we call create range. And that will just take any enumerable and create an immutable array. So this struct will internally now contain a normal array, integer array, with a copy of all the values we provided through this. The difference to the read-only collection from earlier is that read-only collection is a wrapper around another data structure that holds the data. So we had on the first level the read-only collection, which internally stores a list, which then internally stores an array. And immutable array is directly contains the array with the data. So it's one level less of nesting. Plus immutable array is a struct, not a reference type, which has some consequences. For example, there are static array. Wait, did I get that? Do you remember it wrong? Oh, there it is. So for example, ImmutableArray.Empty, just accessible as a static for the templated version. We can also have access to values like as default, because it's a struct, it's a value type. You can just have it be created without a constructor. Like, for example, you create an array of immutable arrays. Then each member by default is a default value, and you need to check, is it empty, or is it just a default because it was never initialized? Because that's a difference. Is default just means it was never initialized. Is empty means it was initialized, but it contains no data. There's also an is default or empty for convenience. But those are consequences of it being a struct. You sometimes have to be a bit more careful with it. And anyway, this is one way to create it. There's also extension methods for it. You can, for example, use to immutable array like that, which is effectively the same. So we can use ImmutableArray.createRange and give it the IMutable. We can also use an extension method for a link extension that has the toImmutableArray, similar to toArray. It makes a copy, it puts that in an immutable array. We can also use some newer features, this collection expression, for example. But I'm still getting used to collection expressions because there are a lot of varieties that all look very similar. It's always just the square brackets with some variation of value in there, dots in there, dots and values in there, maybe a @ sign. It's used a lot, and if you're not exactly sure what they do, then this is confusing. And I still need some getting used to it, so I prefer so far to explicitly write out what I'm doing, like this or like that. So in a case like this, I'm using none of these. I'm actually doing something completely different for the sake of performance and because it makes the code a bit more clearer without costing as much. So right now I'm creating a list to fill up with data, and then I convert that to an immutable array. And that works by copying all the data from this list to this immutable array. It makes a full copy of everything. The read-only collection just wrapped around the existing list, and that's it. The same array was reused all the time. But for the immutable array, we create a second array, copy all the data, and then we drop the first array inside this list. So performance-wise, not so great. We copy the full array. I mean, I don't expect millions of players, so that's not really a big impact, but in theory, you might have a situation where copying the data over might be not a good idea. But immutable arrays are very strict because they have to be ensure that the data is immutable. And if they just take a reference to health, like a read-only collection, then we can still change the original data and therefore change the data you would get from the immutable array. That's unacceptable. So they have to make a full copy of everything. If you know what data you're gonna get at the time of creation, you can use a simple workaround, a sort of exception for the rules for immutable arrays. ImmutableArray.Create.Builder. Don't get confused by the spelling here. This is technically its own class. This is an immutable array builder. The way it works is it's a nested class, an internal class of immutable array, and specifically of the generic immutable array. So we have the class, let me just quick demonstrate, public struct, actually in this case, immutable array structs. MR, it's immutable array, and it's generic. And internally we have public, was it a struct as well? Or was it a class? Okay, that was a class. public class builder. So we have the immutable array, the generic version, and internally it has a nested class builder. That's what we have here. And this builder is basically list. The same way list works, you can also use builder. Builder is fully read and write. You can adjust this any way you want. I can just builder.add. I can also do builder I equals 10, no problem. Builder.remove all. Basically all the methods I have for list also in the builder. And I also can, just like with the list, include the capacity beforehand, player count. So when I create the builder, it internally will initialize its cache with exactly player count spots in the array. So the array internally will be exactly this big. And when we add stuff in here, well, we are only filling the existing array. We're never gonna run out of space. And by the end of this loop, builder will internally contain an array with exactly one entry for each player. Not more, not less. And now I can use the builder we have, and we can either call toImmutable, which is basically the equivalent of calling it toImmutableArray, or making the immutable.createRange and then passing on the builder. But something unique the builder can do is move to immutable. Now this is a bit dangerous. You have to be careful. This will just take the array of this builder directly. The array it internally has used so far to fill up, and it will pass on that actual reference, that actual array, to the immutable array we're creating. So we don't copy the data, we use the same array again. Saves a lot of performance. But it has a requirement. The array needs to be filled exactly 100%. We have to completely fill up the internal array of this builder. Remember, the behavior is just like a list, which means every time the array is too small, let's say the array starts with 4 spaces of space, an array with 4 items, when we add the 5th item, the list, or the builder in this case, will first create a new array with more space. Let's say it doubles it up, so it creates an array with 8 items of space, array of length 8. It will copy in the first 4 entries you already have, and then place the 5th entry you just added. That still leaves 3 spots unoccupied, because they are reserved. If I were to use the move to immutable in that case, it will throw an exception, because of the 8 spaces of that array, only 5 are used. And that's not acceptable. The immutable array will only contain as much data as it has to. The array needs to be fully filled. In our case, we know exactly beforehand how much space we're gonna need. Player count items. 0, 1, 2, 3, 4. And we're gonna fill it up exactly that many times. So we know in this case our code will have exactly that many spots filled. The array inside the builder, the internal cache, will be filled to 100%, so we can use move to immutable. There are no unused spots, and we can keep the efficiency up. Plus, other than with a list, using the builder makes it very clear to anyone that reads it that we intend to use this for just filling an immutable array. There's no other use. If we had to use a list, we might have to check if the list is used anywhere else. Do we use that reference for anything other than filling our immutable array? Was there maybe the intention to use it for something else? Can we remove it safely? Is there something else that's missing in here? Is that simply a bug? But by using ImmutableArray.Builder, we have the full functionality, and we have a very clear sign that this is just the builder. This is just to initialize and create an immutable array. And we don't lose any of the performance. All right, so we got the immutable array. We filled the player help. We can read it down here just fine. What about changing the value now? we specifically made the array immutable, so you can change the values. It's intended to not be changed, but now we need to change. Well, this is a bit impractical, depending on the situation, but what you can do is player health. We change the entire array. The immutable array actually does have methods. We have an add method. We have remove add or remove all. We have inserts. And we also have set item to change a specific value, which is what we want right now. This function, however, will not change the existing array. It is immutable. We are not allowed to change it. But what we can do is we make a full copy of it and then change that one spot in it after we created the copy, and then return that as a new immutable array, which is a full copy of the old one, the original one, with just one change. It should remind you of something. It's the same logic as with records. We take the original and we make a copy of it and make a simple change to it. That's exactly what we do when we make changes to an immutable array. We don't change the existing immutable array, we create a copy that has the changes applied to it. And we can now store this. Wait, what's going on here? Player.playerHealth equals players.setItem. So we create a full copy, change that one value at this one index, and then store that as player health. And then next loop, we make a full copy, change the next item, store that. And repeatedly make a full copy, change that one value, make a full copy, change that one value. Not ideal. Especially after we just spent some time making the constructor a bit more performant, we make dozens of copies potentially. I mean, for 4 players, it's just 4 copies of an array with 4 items. It's not that bad, but it's still not ideal. Or we can reuse the same logic we had for the builder. We can go in here, we can make one copy of it, and take playerHealth.toBuilder, the reverse of what we did up here. Builder had a toImmutable, or the move to immutable in this case. And immutable arrays themselves have a toBuilder, which gives us another builder, which has a full copy of the data inside. And the builder itself, of course, can be just modified as we like. Builder I. Not that. Maximum help. And now we can just change player health equals builder move to immutable. Because we filled the array by using the existing immutable array, ImmutableArray.toBuilder. We know the array is filled at 100% capacity. And we don't remove or add anything, so we know the array is still filled completely when we make this call down here, so move to immutable is safe to use again. So for the level up, we make one copy of the array, make changes in that one copy, and then safely use that copy for further access to player health. And this leaves us with an interesting option. We can now make the log only for the builder. It's actually like this. So we log access to player health and just create a builder of that. Basically, we make a safe full copy, track the builder, we modify the builder, and then we take another log, and it should be like that, to store the modified builder again. That's one option. This has the interesting side effect of when we level up, we make changes to the player health at that moment, and any changes that occur while we are modifying the health and make the level up preparations are basically lost. Because player health is then set to a copy we made earlier. Which might be intentional. I mean, for us, that makes sense. The level up should reset all the health. And any changes that happen between these parts are ignored. So even if a player suddenly loses health to the point of being dropped out of the game, we're just gonna ignore that. Which might be wanted, might also not be wanted, in which case you can of course lock the entire part. Now we can also modify this down here. We don't want to make a full copy of that. We don't want to make any copy of that actually. We want to just get a reference to that. And when I say reference, I mean copy of that. And we use that immutable array now. Because it is immutable, we know that nothing will change it. We don't need to make a copy. We can guarantee that this immutable array will not be changed anymore. It might be from a different point in time. After we make this call, there could be still a level up that creates a new immutable array with new health values, but we're still based on the old ones. And when someone else now accesses our class and makes modifications to it, we can be sure that this method will not suddenly mix different states. It will not suddenly mix different moments in time to check what's the maximum health. Because we just create a copy of the immutable array, not the array inside, which is a reference, just think of it as a copy of the reference. That might be the easiest. Effectively, it is just internally, it's just a struct which internally has a reference to an array on the heap. So you can treat it sort of like a reference. We make a copy of that, and we are guaranteed that this will be the same data no matter how long we take to iterate through the entire loop. That's just the important part. We only have to lock it once to get the actual array, the immutable array, and after that, no matter how long we take, it will be a consistent array throughout the entire operation. Nothing will be changed while we iterate through here. That's the important part. No matter what we add to the rest of the class, we can be sure of that. Alright, so that's immutable array. Also something I use quite a lot. Combination with other types of data structures that are also available, that are also immutable. So I said earlier how there are different variations for read-only. There are also different variations of immutable. So we have immutable dictionary. We have immutable hash sets. I think stack and queue are also available. What else do we have? Eric's, no, that's not interesting. Immutable lists, okay, that's available. Sorted sets, list queue. Yeah, those were the important ones. I usually use either the array or the dictionary. I don't think I've used any of the other immutables so far. But they are available, and they're very useful. In general, immutable is very useful. Immutability in general is a useful property to have in coding, especially when doing multi-threaded systems. Not having to do some separate trickery here for locking, just relying on I get the value once and I know this value will stay consistent no matter how long I use it. That is so valuable in multi-threading environments. Imagine this array constantly changing and having to actually lock up access to it through the entire operation. That can be a bottleneck in some cases. We avoid that with immutable. That makes multi-threading very safe. A lot of issues you can run into with multi-thread systems can be avoided by just using immutability. Downside is of course that you might have a performance leak in terms of memory. You have a lot of copy operations potentially, because you can't reuse the same object constantly. you have to create new objects, and every time you make a change, we have to create a new object with new data, even though most of it doesn't change maybe. Like this level up operation, for example, the old system which just constantly would change the value and copy all the data again to change one value. Depends on the application. I think usually immutable is good, but you may run into an issue for certain situations where having a reference type is preferable. You just have to be sure that you handle that in a delicate manner, at least for multi-threading. I'm thinking about if did I forget anything? I think that's it. I think that's all I wanted to show you today. We had the record, the use record, what it's good for, and immutable array, how you can use it. We had the builder. I think that's it. Homework. I don't think today we're gonna have any homework. You can try to play around with these, but they are very specific tool that you might not need. But if this lesson gave you an idea for how to improve some existing code of yours, go ahead, try it. But otherwise, there's no homework for today. And that's it. Thank you for joining in. See you next time.